The Sun has been shining for about 4.6 billion years, and it's currently in the phase of its life known as the main sequence. It is primarily converting hydrogen into helium through nuclear fusion in its core. This process is estimated to continue for another roughly 5 billion years. Eventually, the Sun will exhaust its hydrogen fuel. As it does, it will expand into a red giant, swallowing the inner planets, including Earth. After this phase, it will shed its outer layers, leaving behind a hot core called a white dwarf. A red giant is a phase in the life cycle of a star, including stars like our Sun. It occurs when a star has exhausted the hydrogen fuel in its core and begins burning helium into heavier elements. During this phase, the outer envelope of the star expands, causing it to become larger and cooler in temperature. The name red giant is derived from the fact that these stars appear reddish in color due to the lower temperature compared to their earlier, hotter phase as a main sequence star. The expansion of the outer layers of a red giant is a consequence of complex stellar processes, including the production of heavier elements in the star's core and changes in its internal structure. Ultimately, our Sun is expected to go through a red giant phase in about 5 billion years, as it nears the end of its life cycle. During this phase, it will expand and likely engulf the inner planets, including Earth, before eventually shedding its outer layers and becoming a white dwarf. After a Sun-like star exhausts its nuclear fuel and goes through the red giant phase, it sheds its outer layers, forming a shell of ionized gas known as a planetary nebula. What remains at the center is a hot, dense core called a white dwarf. A white dwarf is primarily composed of carbon and oxygen and is no longer undergoing nuclear fusion reactions. It's supported against gravitational collapse by electron degeneracy pressure, a quantum mechanical effect that prevents electrons from being compressed into the atomic nuclei. Over a very long timescale, a white dwarf will gradually cool and fade, becoming a cold and dark black dwarf. This process, however, takes much longer than the current age of the universe.